Welcome to Homework Lib.
Over here, since I don't have access to the ALEKS Data resource, I'm going to use the Chang book of Chemistry, 13th edition, and the appendix on thermodynamic quantities. So for this reaction, what we want to know is the equilibrium constant K at 25 degrees Celsius, which is equal to 298.15 Kelvin. Remember that if we are at equilibrium, the value of delta G is equal to 0, and delta G was equal to delta G standard plus RT logarithm of Q. If delta G is equal to 0, then Q, we can replace it by directly the equilibrium constant K. So delta G standard is going to be equal to minus RT logarithm of K. Thus, the value for K, our equilibrium constant, is the exponential of minus delta G standard divided by RT. So we want to know what is going to be the value for delta G on this reaction. For this reaction, what we're going to get is that, remembering Hess law and the fact that the delta G of formation of the elements under standard state are going to be equal to 0, that means that the delta G of formation of O2 and of Cl2 is going to be equal to 0. This is going to become 4 times the delta G of formation of iron chloride as a solid minus 2 times the delta G of formation of iron oxide as a solid. The value for delta G of the reaction that I get from this is going to be equal to 146 kilojoules from the results that I got, which is the same as 146,000 joules directly. So now we can replace this into our equation for our equilibrium constant. So this is going to be the exponential of minus the value for delta G of reaction, which was 146,000 joules, divided by R, our gas constant, 8.314 joule per mole Kelvin, times the value of temperature. In this case, at 25 degrees Celsius, this is 298.15 Kelvin. So the result of this exponential is going to be equal to 2.63 times 10 to the minus 26. In this case, I'm going to keep only 3 significant figures because I'm assuming that the results that are on the ALEKS data table are up to 3 significant figures. So the only possible difference is that if the delta G of formations on these compounds differ from the ones that I got, that in my case it was minus 334 kilojoules per mole and minus 741 kilojoules per mole respectively, then the delta G of the reaction is going to change. So the only thing that you need to replace in your equation is going to be the value over here. Okay? So with that, it would be all. Thank you very much and have a good one.